Hi everyone, welcome back to the channel. In today's video we're going to be looking at an example of how to find the inverse Laplace transform of a Heaviside step function. So here is our Laplace transform and we want to find the inverse of that. So remember, when you have your transform, your variable is s. When you find your inverse Laplace transform, you're going to find it in terms of t, your variable t. So if we look at the function that we've got here, you can see you always start with your denominator first of all, right? So if you look at s squared is on your table of Laplace transforms. Once you've done and you've figured out where your denominator fits in, you then go to your numerator. So you'll see from your table that you don't have anything that looks like this on your table. So what we're going to do is we're going to split this up into two terms. And that is minus 5s over s squared, right? So now you've got two terms. The first term you can figure what the inverse transform of this is going to be. This is just going to be t, right? Because it's the number 2 on your table. If you look at your second term, you'll see that you've got two parts to this. You've got an exponential part and you've got the 3 over s squared over here as well. So when you see this exponential e to the power minus 5s, you'll see on your table that you don't have anything that looks quite like this, but it is very similar to the Heaviside step function. So we're going to put this in the form of that second shifting theorem. And let's just remind ourselves what that is. So the transform of a function where you have f of t minus a times u of t minus a is going to be e to the power minus as times the transform of f of t. Okay, so what we want to do is we want to take the second term and put it in the same form as this side of the second shifting theorem. So we want it to look like this. So we want the second term to be in the same form as this one here. And what that means is, if we write the first part out like that, it means we need to have the e to the power minus 5s on its own. So I'm going to put the 3 here, e to the minus 5s on its own. And then I'm going to need the transform of 1 over s squared. But it is in fact the inverse of that. That's what I want. So the reason I've written it like this is that when I say the transform of the inverse, it means that these two actually cancel one another out. So all you've done is you've changed the form of what your function looks like, just so that you can match it more closely to the item on the table that you want to use. So then I'll say that this is 1 over s squared minus 3 e to the minus 5s, and the transform is going to be the inverse of 1 over s squared is just t. Then, let's move this up. Then, now I can take the inverse transform. So I'll take the inverse transform of f of s. The inverse of 1 over s squared is going to be t. Then this, we can use our second shifting theorem now to find the inverse. So we're going to be moving from, if we look at the second shifting theorem over here, we're going to be moving from our right-hand side to our left-hand side. So that means that we're going to need the 3 here times, we have the shift in terms of u, so it's going to be t minus 5 and then the function of t, including the shift, is going to look like that. So that means that our final function is going to be t minus 3 times t minus 5 with the step function t minus 5. And that is our answer. I'll see you next time. Bye.
A few moments later.
Now, this answer can be written in terms of interval notation. Now, interval notation is where you write it as the discontinuous function. So we know we'll have f of t equals our intervals here. You see that the step function is t, u of t minus 5. So that means you're going to have t between 0 and 5, and you're going to have t which is greater than 5. When t is less than 5, it means that this u of t minus 5 is 0. So the only thing you're going to have left is your t. Where t is greater than 5, u of t minus 5 is equal to 1, which means you're going to have t minus 3 times t minus 5. So then, if I simplify that second part, I end up with f of t equals t, and we're going to have 15 minus 2t, where t is greater than 5, and it'll be equal to t, where t is less than 5. So these are the two forms that you can write your function as. So this would be the Heaviside step notation, and this bottom one here will be your interval notation. Well, I hope you found that interesting or helpful at least. I will see you in another video for another example. Bye!